test review. These are things that you will see on your 171 test. So I'm just going to take and emphasize some of the things that you're going to need to utilize. And we're going to look at how we can use our graphing calculator to help us as well. So very important, if you do not have a graphing calculator, please, please, please get one before your test. All right, so first problem, we're looking at 7x squared minus 2x, and it wants us to answer the following questions using a graphing calculator. Very important thing to help you answer the questions. We're going to round to 1 decimal. Okay, so very important things. We have our equation, tells us to use a graphing calculator, and most importantly, it tells us to round to 1 decimal place. This could make or break your answer. So, the very first thing it asks is the equation a function? Why or why not? Well, in order to really truly figure that out, I'm going to go to my calculator. I'm going to go to my y equals. There you go. I'm going to go to y equals, I'm going to clear it out, and I'm going to put in 7x squared minus 2x. I'm going to take a look at my graph. It's a parabola. If you can't see it, I'm going to teach you something really good. So zoom 6. It sets your graphing calculator back to the standard view. Okay, so zoom 6 resets your calculator. So we take a look at it, we notice that it's a quadratic. Well, if we know anything about quadratics, we know that if we were to do a line test, what's it called, a vertical line test, that we know that it is a function. So we say yes. It says why or why not. Well, we know why, because we did a vertical line test, meaning we took our graph, okay, and we drew our vertical lines, and it only went through once each time. Now, again, we take a look at our graph. We know that, what is the domain? Well, the endpoints go up to infinity. So we know that the domain is from negative infinity to positive infinity. Now the range. It says, what is the range? Well, in order to find the range, I have to know what my absolute minimum point is. So I'm actually going to have to find the minimum first. So we have to find the minimum first. So I'm going to teach you how to do that if you don't know how to do it already, which I really hope you do. So what we're going to do is we're going to take and we're going to zoom in to our calculator. So hit zoom in, enter. Okay, and I'm going to take a really close look at it. And I know to calculate it, I'm going to hit second calc. Remember, hit the yellow button, look for the yellow words, so second calc. And I know I'm going to calculate the minimum. So I'm going to go down, hit enter. Now it gives me a cursor. I know that to calculate the minimum, I need to go left of it, hit enter, and then I need to go right of it. Hit enter, hit enter again. Oops, I hit it one too many times. Let me do it one more time. So second calc, minimum. Again, I go to the left of it, because we always read our graph from left to right. We always go to the left, and then to the right. Enter, enter. We want to go far enough left and right that it can get a good estimate of what it's going to be. So what is the absolute maximum, or minimum, sorry? Looking at my graph, it tells me that I have 0.14 and then negative 0.14. Well, it told me to round to 1 decimal place, so those actually round down to be 0.1 and negative 0.1. So my minimum is 0.1, comma, negative 0.1. Okay, if you have to, or if you like to, you can also choose 0.1. Depending on the teacher, some people like it this way. So we know that we have a minimum at this point. Do we have a maximum? Absolutely not. We have none because it goes up to infinity. So for the range, remember, range is the y values So, okay, I know I'm going to take and use that y value, and I know I read it from bottom to the top. So I know my y value starts at negative 0.1 and it goes up to infinity. Now to calculate zeros. So again, I'm going to actually take and I'm going to zoom in one more time because I really, really want to be able to see exactly what I'm doing. Whoops. It didn't quite zoom in where I wanted to, so I'm going to hit zoom 6, enter. I'm going to reset my calculator. And now I'm going to take and put it where I need it to be, and I'm going to hit zoom in so I can get a really good idea of it. Much better. Okay, so I'm going to hit zoom, calc again, and this time I'm calculating zeros. I have two of them. The first one, I notice, occurs at 0, 0. So I know the very first one is at 0, 0. Now I'm going to calculate the other one. So I go to my calculator. I have hit zoom calc. I'm going to go left bound. Well, left bound whenever you're doing 0 means bottom to the top. So I'm going to hit enter. I'm below my line. Now I'm going to go above my line and hit enter, enter. And it tells me, actually zoom calc, that it was at 0.28, sorry. 0, sorry. I'm going to go below, enter, above, enter. Again, it tells me it's at 0.285. Well, remember, I'm supposed to go to one decimal place, so I know that the next one is actually going to round to be 0.30. Now it says, what is the interval of decrease? Well, again, I look at my calculator. I know that the decrease occurs if I'm reading it from left to right. From the left, it's going down to my minimum. So I know that it's going from negative infinity on the left-hand side of my graph to my minimum, right, which is the x value of my minimum, because we only use x values when we're doing intervals of decrease and increase. So I know it goes to 0.1, and it's on my graph, so it is bracketed. All right, now it asks, what is f of negative 11? Well, all you need to do to figure that out is to take and plug in negative 11 into your original equation. So then you can go to your calculator, you can go second quit, and you can plug in your equation. So we have 7, negative 11 squared minus 2 times negative. Remember, the negative is actually at the bottom of your screen on your calculator. So negative 11, and then we hit enter, and I get 869. Now, number 5, something that we've been doing. We're going to look at an equation. First thing that we're going to do is we're going to tell what the parent function is, okay? Parent function, there's only a handful. If you're using your cheat sheet, you would know that if there's a square root in my problem, I know that my parent function is f of x equals the square root of x. Now it asks, what are the transformations? Okay, so I'm going to go to my equation. I'm going to notice the very first thing is I have a negative. That negative means that it's reflected over the x-axis. Now, I'm going to move on to the next thing. I have a plus 1 inside of my radical. So I know it's going to be the opposite. So instead of it, don't get confused. This is not right 1. This is actually left 1. Right? And so you don't get confused, we're going to look at the last one, and it's going -1. I know that if it's plus or minus at the very end of my equation, I know that it's going to go down 1. Now, very important, this says graph the function without the aid of a calculator, meaning you're going to need to show all of your work. Okay, very important. You will get points taken off if you do not show all of your work. So my suggestion is you're going to need to draw a table. So we have x, we have our equation, which is negative square root of x plus 1, and then a -1 at the end, and our y. All right, so very first thing, I already know from my left 1, down 1, I know that the first solution to my problem or point on my graph is going to be a -1, -1, because it tells me I'm going left 1, down 1. So left 1, down 1, I know that it starts right here. Now, I'm actually going to take and I'm going to say, look at 0, because these usually go to the right. So I'm going to plug in a 0. Well, 0 plus 1 is 1. Square root of 1 is 1, but there's a negative out front, so it's a -1 minus 1, so that gives me a -2. So I have a point at 0, -2. Now I'm going to plug in, well, what I know, I'm going to take a look at what's underneath the square root. And I'm going to go, okay, what numbers do I know really quickly that give me a square root? Well, 4 and 9. Those are the smallest numbers I know that I can take this clean square root of. So in order for this x plus 1 to be 4, I'm going to add a 3. So that I get negative square root of 3 plus 1, which I know is 4. So that's a negative square root of 4 is 2. So -2 minus 2 is -3. Now again, I look and I go x plus 1. What's the next whole number that I know I can take the square root of? Well, 9. In order for this to be 9, my plug-in has to be 8. So I get negative square root 8 plus 1 minus 1. Well, the square root of 9 is 3. So -3 minus 1 is -4. All right, so now I have at least 4 points that I can graph. So I'm going to graph them. I have 0, -2, which I already did. I have 3, -3. So 1, 2, 3, down 3. And then 8. So 3, 4, 5, 6, 7, 8. And then down 4. So here's my graph. Remember, always put an arrow at the end. All right, so we graphed our function. Now we're going to move on to piecewise functions. Piecewise functions are 2 graphs included in one. Okay, so there are some things that I'm going to notice first. First one, I have an x less than 1, which means that I'm going to have an open circle on this graph. And then I have an x greater than or equal to 1, so I know on this one, I'm going to have a closed circle. All right, and then 1 is actually where everything kind of shifts around. So I know that on my line at 1, I'm going to go ahead and just put a little yellow line so that I know on this side will be this part of the graph, and it'll start with an open circle. And then on this side of my line, I'm going to have a closed circle, and it's going to go this way. So we have x squared plus 1. I know that it starts at 1, and I need to include all the numbers below it. So when I go to do my, whoops, I didn't mean to put that in green. So I know I'm going to have my x, and I'm going to have my x squared plus, my x squared plus 1. I know it has to start at 1. When I plug in a 1, I get 1 squared plus 1, which is 2. So I know I'm going to have a point at 1, 2, and it's going to be an open circle. Very important. It's going to be an open circle. Now, everything to the left. So I know my next number I'm going to plug in is a 0. Well, 0 squared plus 1 is 1. Then I'm going to plot it. I have a 0, 1. Now I'm going to plug in a negative 1. So I get negative 1 squared plus 1, and that's 1 plus 1 is 2. So at negative 1, 2, I have a point. I hope I know that because this is an x squared, I know that this is going to be a quadratic. So it's going to look like a parabola. All right, so my next point I'm going to plug in so that I could at least point a couple. I'm going to do negative 2. So negative 2 squared plus 1, that's 4 plus 1, which is 5. So negative 2, 5. Last but not least, I'll plug in a negative 3 so that I can plot 5 points, which is usually a pretty good rule of thumb. So that I have a negative 3 squared plus 1, which is 9, plus 1, which is 10. So this is 5. Go over 1. 1, 2, 3, 4, 5, more 5. There we go. So it's never complete until you graph it. Mine's a little wonky, sorry. Now we're going to move on to our x plus 3. Remember, I know that it's going to include my 1. So when I plug it in, I know I'm going to get 4. So I have a closed point at 1, 4. So 2, 3, 4. Closed circle. Now my next point, I have a 2. So 2 plus 3, it's 5. So that's just one more point up. 3. 3 plus 3. 6. So I hope you notice that there is a pattern. It's just going up 1 over 1 this entire time, but because I don't know your teachers, you're going to make sure that you write down your work so that they also know that you did your work. So 5 plus 3, 8. All right, good. Remember, it's not done until we completely draw our line. So there you go. Piecewise functions. You're going to pay attention to your less thans so that you know whether or not it's going to be open circle, closed circle. And you're going to pay attention to what direction they're going. They're telling you what direction on your graph it's going to go. So don't do any of the points on the other side of that line. Again, I draw my little imaginary line so that I know not to cross it.